All right, before we get started on completing the square, which is a way to go from standard form into vertex form for a parabola, we're going to look at what a perfect square trinomial is. So let's say I had something like x plus 5, that binomial was squared. Well, that's going to create a perfect square because I'm squaring something. So if I write out x plus 5 times x plus 5, just like I've done next to it, and I FOIL that out, I'm going to get x squared. My outside is going to be plus 5x. So first outside. Then I'm going to do the inside, and I'm going to get another 5x. And then the end is going to be 5 times 5, which is 25. All right, so if we take a look at what happened, we ended up getting 5x as a term. We ended up getting twice. So that when we simplify this, we end up with x squared plus, well, we're going to double that 5x term because we have two of them, so it's 10x plus 25. I'm just going to move my thing over a little bit here. Okay, plus 25. All right, so if you notice, this perfect square trinomial kind of has a couple features. Its middle term is like the double, in other words, times 2. It's a double of positive 5. In other words, it's positive 5 times 2. And the end is that same number of 5 squared. Okay? So the middle is a double of 5, and the end is a square of 5. All right, let's see if that's true in the next one. So let's FOIL it out. X times x gives us x squared for our first term plus 7x for our outside. Well, there's where the double comes from because we end up getting two 7x's. And then the end, we get a square because 7 times 7 is 49. So again, we get x squared plus 14x plus 49. So we can see this sort of standard setup here of a perfect square trinomial, where that is the double of a number, and that is a square of the same number, in this case, 7. All right, so the last one, let's just see if we can skip the foiling thing and figure out what it's going to be. Well, we know x times x is going to give us x squared. Okay, we might look at this and go, okay, if I double that, I'm going to get the middle number. So double, or negative 3 times 2 is negative 6x. And then negative 3 times negative 3 is positive 9. So that's a quick way to do that. And once again, this was that negative 3 number times 2. And this is the negative 3 number squared. Okay? So every perfect square trinomial is the same. So what we're going to do is we're going to say start with a couple of terms and kind of do stuff like this. We're going to go x squared plus 18x plus some number. How do we know if this is a perfect square trinomial? Okay, let's say that that's going to be something squared. All right, if we know that that's a perfect square trinomial, well, what do we know about it? We know that this is the double of some number. Okay, so clearly that is the double of 9, positive 9 times 2. So then according to that, then this n number would have to be the square of that number. So in other words, it's got to be 81. Okay? Because this is the square of that 9 number. And then we also know in our perfect square trinomial, when it's written as a binomial being squared, it's x plus 9. There's that number again. Okay? So just looking again at what a perfect square trinomial is, and the last thing I want to mention before we move on is notice, because the last term is always a positive times a positive gives us a positive. A negative times a negative gives us a positive. So since that last term is a square, it's always going to be positive because if you square a positive or you square a negative number, you're always going to end up with a positive result at the end. So this last term, or that last sign, is always positive. All right, Let's go now and move on to the notes and take a look at what completing the square is all about. All about. Okay, so, all right, we're going to basically what we're trying to do here is we're trying to take the standard form of a parabola, which, as we've seen in previous videos, isn't that useful, and we are going to make it into vertex form by this thing called completing the square. So what does it mean to complete the square? Well, let's say, just to have that one more example, let's just do x squared minus, I don't know, 20x. Okay, to complete the square, that's saying, well, we know that if this is a perfect square trinomial, that's going to have to be a plus. It's kind of saying, to complete the square, what does that last number have to be? Okay, so if you think about it, again, we recognize that this middle coefficient there is the double of something. Well, it's the double of negative 10. And then this term here is going to be the square of that same number. So then this is going to be plus 100. Okay? So we've completed the square. And if we wanted to write this as a binomial, something being squared, well, it's x, well, minus 10 is that number, so x minus 10 is what's being squared. Okay? So completing squares is sort of a shortcut of figuring that out. And we're going to do one more example, this time with something that's not so nice to work with. So let's put it on line there. All right, so the next one, let's say we had x squared minus 5x. Okay? All right, so this one's not going to be as pretty because 5 is an odd number that if you think about the number here that's being doubled, okay, what number would it have to be? Well, we could think of it as 2.5 times 2 would give us 5. But let's do it this way. You know, here I wrote, above I wrote, we kind of figured it out in the previous example, but notice that negative 10 is half of negative 20. Okay? So one way of coming up that number in the box is to take half of the middle coefficient. So then what's half of negative 5? Well, half of negative 5 is 1/2 of, in math, means times. So 1/2 times negative 5 over 1 is just negative 5 over 2. Okay? Negative 5 over 2. So in other words, to find half of an odd number, just go stick it over 2, because that means divided by 2. So that means that's our sort of half number that we have to work with. Just to be consistent, I'm going to put that in a box. I'm going to reset and put that in a box. Okay. So there's our half number that was being times by 2 to give us negative 5. And then our n number here, well, we know that that's the square of the number in the box. So what is negative 5 over 2 squared? Well, when you square a fraction, it's top times top, 25. Bottom times bottom, 2 times 2 is 4. And here we can see negative times negative is positive. So we always know that last number is going to be positive, a positive number, so positive 25 over 4. Okay? So it's a little weirder looking, but the same principles apply. And again, if we wanted to express this here as, sometimes things disappear and I'm not sure why. Okay, there we go. So what would be squared here would be x minus 5 over 2. All right. So let's use that to find the vertex form of some parabolas. So in part 1 here, we're just going to start out with something that's just fairly straightforward, like there's no coefficient. No coefficient. All right. So what we're going to do is let's start by just focusing on those first two terms. So I'm going to go x squared plus 6x, and then I'm going to bring the minus 12 over there. I'm just going to leave a big fat space in there so that I can complete the square. All right, so what I'm trying to do is I'm trying to make a perfect square trinomial, just as I did in the previous example, that starts with an x squared plus 6x. All right, so let's go through our thing. We're going to go, well, half of 6 is 3. So 3 is our number, positive 3, because half of positive 6 is positive 3. So 3 is our number that's being doubled. So then that is plus 9. Okay, I'm going to put that in green. Plus 9, because now we've completed the square. Okay, so the only problem is we can't just start adding 9 whenever it suits us. But what we can do here, right next to it, is subtract 9 so that, basically nothing happened. So if I add 9 and subtract 9, it kind of neutralizes out, and it's kind of like we didn't do anything. So no harm done. But what this allows us to do then is to take a look at these first 3 terms and say, oh, okay, that's a perfect square trinomial of x plus 3 squared. And then we take the last numbers that aren't in the perfect square trinomial, and we just simplify those. So negative 9 subtract 12 is minus 21. Okay, so here we've got the vertex form of a parabola with an a value of 1. Our p value is negative 3, and our q value is minus 21. So here, if we wanted to graph this thing now, we know that the vertex is negative 3, negative 21. Okay, we know that it hasn't been stretched, but since a is positive, it opens up. And from the last video as well, we could look at the standard form and know that that's the y-intercept. Okay, so there's a bunch of things that we can get then. So that's basically an example of putting something into completing the square. Okay, so I'm going to do the next 3 here and sort of show you how the process changes a little bit when it's odd numbers in the middle, like in B. All right, so I'm just going to do this quickly so that I'm not chewing up all your time. So I'm going to take x squared minus 10x, and I'm going to separate them from negative 18. Then I'm going to think of what would have to go in the third spot here. I know it's going to be plus, so I might as well write that in. What would have to go there to complete the square? Well, I'm going to get that number by going half of the middle coefficient of negative 10. Half of negative 10 is negative 5. So that's the number that when I square it, I get this end number of 25. Okay? So if I do that, I have to atone for it right away by subtracting 25. So I didn't really change things. Okay? Then I take the first 3 terms and I group them into the perfect square trinomial, x squared minus 10x plus 25, which can be written as x minus 5 squared. Okay? Then I take those 2 numbers and I combine them together to give us minus 43. So notice that in the first thing, the a value at the front before the x squared is the same as the a value down there. So the a value never changes. Okay? That's the same. Okay, so whatever a is in standard form, it's also in vertex form. All right, let's take a look at b. So y is equal to x squared minus 5x, scoot the 8 over into there. Then I know it's going to be plus some number. What number is that going to be? Oh, once again, I'm looking for a perfect square trinomial there. So how do I find that number? I take half of the middle coefficient. Of means times, 1/2 times negative 5 is negative 5 over 2. To complete the square then, I need to place the negative 5 over 2 squared at the end. Well, 5 times 5 is 25, 2 times 2 is 4, negative times negative is positive, but we already knew that. All right, to atone for it, we go minus 25 over 4. Okay, so that's steps pretty much always the same. All right, that's a perfect square trinomial, which is y is equal to x. I know it's the number in the box, so I can just go minus 5 over 2 squared. And now I'm going to I'm going to add these last two numbers, okay? So in order to do that, I need this to be 8 over 1. So sometimes when you're doing a question, like this year, sometimes the work, there's a lot of it on a page. So what I might do is over here in the margins, I'm just going to put a little bubble, and I'm going to do this over here on the side. What's negative 25 over 4 plus 8 over 1? Okay, so we're going to make them common denominators. So that would be negative 25 over 4 plus 32 over 4. 32 and negative 5, if we combine, 32 and negative 25, combine those integers, and we get positive 7 over 4. So those things at the end combine to positive 7 over 4. Okay, so there's the vertex form done by completing the square. All right, in the last example, we've got a similar situation. Notice I'm only doing ones where a is 1. Okay, so we're going to start there. So here we're going to have y is equal to x squared plus 11x, bring the 8 over. Okay, group the first three terms together, and it's going to be plus something, so we're going to complete the square. The number that goes there is half of the middle coefficient, positive 11. Half of 11 is 11 over 2. That's the number that is sort of the little magic number there that we have, and we're going to square that. So when we square 11 over 2, 11 times 11 is 121. 2 times 2 is 4. Okay, just going to move this guy over a little bit, and we can't just go adding things without atoning for it, so I'm going to subtract 121 over 4. No harm, no foul. The first three terms become x plus. Little tip here is that whatever this sign is, that's next to the middle coefficient, that's kind of always, the sign that we're dealing with, so I know that's going to be a positive there. Okay? In the previous example, that was a negative. Okay? So just keep that in mind when you're going through these. Okay, so the number in the box is what is the end of that sort of binomial being squared. And then over here in the margins, I'm going to do my actual math of what is negative 121 over 4 minus 8 over 1, common denominator, minus 121 over 4 minus 32 over 4. And if we subtract, or if we combine those numerators, negative 121 and negative 32 as integers combine to negative 153 over 4. So I'm going to write minus 153 over 4. So that's the gist of it. Notice I'm working with fractions as much as possible. This should be a non-calculator section. So it takes a bit of practice, but when the middle number is even, that's nice and easy. So that's the process that you're going to follow through for when there is no coefficient in front. In other words, a is 1.